welcome friends to my YouTube channel. Now on my last lecture I have told about the energy loss in different types of pollutions. Okay, and we saw that for elastic pollution, for perfectly elastic pollution there is no loss of energy, and for perfectly inelastic pollution there is maximum loss of energy. Okay, now in today's video I shall going to discuss a new topic, that is collusion in center of mass frame. This is our topic, that is collusion in center of mass frame. So let us try to first understand what is center of mass frame. Okay, now center of mass means, we assume that center of mass of a body means the entire mass of the body is concentrated at a particular point. Okay, that is center of mass. Entire mass of the body is concentrated at that particular point. Okay, so entire mass of the body is concentrated at that point. Okay, so if we consider the origin of the coordinate system, that is, say this is a 3D coordinate system frame of reference. So if the origin of the coordinate system, that is O, coincides with the center of mass, that means we can place the center of mass here. That means what happens? The center of mass and the origin of the coordinate system coincides each other. So then this is called center of mass frame of reference. Okay, so center of mass and origin of coordinate system coincides. Okay, then it is called center of mass frame of reference. Okay, so origin of the coordinate system coincides with the coordinate system. That means the center of mass is located at that point. That means we can easily say that the position vector of center of mass is 0. Position vector of the center of mass is 0. That means velocity is also 0. And if velocity is 0, momentum is also 0. So we see that the position vector of center of mass with respect to O is 0, since these two coincides. That means R is 0. So if position vector is 0, velocity is 0, as a result momentum is 0. So for this reason, center of mass frame is called zero momentum frame of reference. Okay, that's why it is called zero momentum frame of reference. Okay, zero momentum frame of reference. Okay, so this is the first thing. Now let us try to understand the significance of center of mass frame of reference. Okay, let us try to understand the significance of center of mass frame of reference, why it is suitable. Okay, now you all know that under the application of external force, the velocity of center of mass remains constant. You all know it from center of mass theory. Okay, so from center of mass theory, you all know that under the application of external force, velocity of center of mass remains constant. Okay, so you all know it from center of mass theory that under the application of external forces, the velocity of center of mass remains constant. Okay, that means you can say center of mass frame moves with a constant velocity relative to what? Laboratory frame. With respect to laboratory frame, the CM frame moves with a constant velocity. That means CM frame is a inertial frame. Okay, so with respect to lab frame, CM frame moves with constant velocity. So CM frame is an inertial frame. Okay, so this is the physical significance. Okay, you all know from center of mass theory that under the application of external force, center of mass, the velocity remains constant. So that means center of mass frame moves with a uniform velocity relative to lab frame. So any frame that is moving with a uniform velocity relative to an inertial frame is also an inertial. So we can conclude that CM frame is also an inertial. So this is the significance of center of mass frame. Okay, now today we shall discuss the collision in CM frame. Okay, suppose we take lab frame and here we take CM frame. So here if we consider two objects M1 and M2, so before collision the velocities in lab frame are U1 and U2, and that in CM frame are U1 dash U2 dash, and after collision the velocities in lab frame are V1 and V2, and that in CM frame in V1 dash and V2 dash. Okay, so we denote these quantities. So since center of mass frame is zero momentum frame, what we can write before collision? Since it is a zero momentum frame, before collision the net momentum is zero. That means this is zero. Okay, so we can write M2 U2 dash, this equals to minus M1 U1 dash. So U2 dash will be what? Minus M1 by M2 U1 dash. So what will be my mod U2 dash? Simply M1 by M2 into U1 dash. Okay, that we can write. Now similarly, before collision in center of mass frame, if we put M1 V1 dash plus M2 V2 dash equal to 0, so from here we can write mod V2 dash, this equals to M1 by M2 V1 dash. Okay, by using the concept that it is a zero momentum frame of reference, we can write this. Okay, now what we can write from energy conservation? Half M1 U1 dash square, that is half m2 u2 dash square. This is half m1 v1 dash square half m2 v2 dash square. Okay, so half cancels, m1 u1 dash square plus m2. What is u2 dash? These squares, that means m1 square by m2 square u1 dash square. This is simply m1 v1 dash square plus m2 v2 dash square, that means m1 square by m2 square v1 dash square. Okay, here here we put the values of u2 dash and v2 dash. Okay, so if we take u1 dash square common, m1 u1 dash square common, so we get 1 plus m1 by m2. Okay, m1 by m2, and if we take m1 v1 square v1 dash square common, this is 1 plus m1 by m2 this. So this cancels, m1 this cancels. So u1 dash square we can write v1 dash square. So simply we can write mod u1 dash, this equals to mod v1 dash. Okay, so we see that velocity before collision and velocity after collision will remain same in magnitude, but the direction will be opposite. That means, okay, if it is in cm frame, u1 dash is along this direction and u2 dash along this direction. Okay, v1 dash will be in this direction and v2 dash will be this direction. So before collision and after collision, the magnitude of velocity remains same, but the direction is just opposite. Okay, remember this thing. So similarly we can easily prove that mod u2 dash is also equal to mod v2 dash. Okay, that I will discuss in my next class. Okay, so what we conclude from this, that the after collision and before collision, the velocities remain same in magnitude but differ in direction. Okay, so before and after collision, the velocities remain same in magnitude but direction is opposite. Okay, it is in cm frame. Okay, so this is the simple theory. Now in my next class I shall going to discuss few other things related to center of mass frame of reference. So video link will be given in the description box. So if you like this video, kindly subscribe my channel and share it. Okay, and if you have any problem, then just write it in comment section. Okay, thank you.